Hello guys, how are you today? So today I'll be I'll be doing the chapter 2 notes and a summary for chapter 2. So, chapter 2, okay, we start chapter 2 learning a concept that we had already taken in grade 9, which is known as Avogadro's hypothesis. Now, Avogadro is a very important scientist. Without him, I'm pretty sure you guys would be happier without him and his hypotheses, or however you say it, his hypotheses, okay? We would not have chemistry as it is today. Okay, what did Avogadro do? Avogadro, he did a bunch of experiments, and then he figured out that all gases, when heated equally, expand by the same amount. He also created the constant of the mole. That's why when you are solving and you will say, okay, this is 1 mole, you will know that this is because of Avogadro. We know that 1 mole has 6.02 times 10 to the power of 23 particles or atoms. So that's why it's very important, or that's why Avogadro's accomplishments were very important for us to get to know what is happening in these particles. So what is his hypothesis? His hypothesis states at the same temperature and pressure, these are very important keywords, same temperature and pressure, okay, equal volume of different gases, so keep in mind, they have to be same temperature, same pressures, and equal volumes. So, equal volumes of different gases contain the same number of particles. So, very simply, Avogadro's hypothesis states at the same temperature and pressure, equal volumes of different gases contain the same number of particles. What you also need to know is that 1 mole will contain 6.02 times 10 to the power of 23 atoms, or let's not say atoms, let's say preferably particles. Okay? So this is just like a quick summary. We move on to the next topic, which is radioactivity. I believe we've taken it so much in physics by the time it's probably engraved in your head. So radioactivity. If by now you don't know what radioactivity means, here's just like a small definition. It is the spontaneous. What does spontaneous means? That means the direct, if you want in some sense. So the spontaneous decomposition of a nucleus, very important term, nucleus, to form different nuclei, or different nuclei. Usually these different nuclei, they are more stable. So why would a radioactive substance decompose? It would decompose, okay, because it's unstable. It cannot exist in nature. Since it cannot exist in nature, it will need to decompose. We call this process radioactivity. So the nucleus itself will become smaller or different nuclei, which are more stable. Okay, then the things you need to know is the different types of radiation. You have the alpha radiation, the beta radiation, and the gamma radiation. Okay, so alpha radiation will release a helium particle or a helium nucleus, which is He. It has a mass number of 4 and an atomic number of 2. Beta particle will release a high-speed electron, which is denoted by E. It does not have any mass. Remember, electron mass is so small that sometimes it's even considered as 0, and it has a charge of -1. Now, gamma, you don't have anything to refer to gamma, you just refer as gamma. So these are high energy photons. And if you were to refer to it, it would just be the letter gamma. This is the Greek alphabet, by the way. So alpha is kind of A, beta is kind of B, and gamma is kind of C. They're the first, second, and third letters. Okay, so now talking about atoms, decomposition, and everything, we first need to understand what is an atom. There have been many scientists over lots of decades who have tried to understand what is an atom, how is its structure, but the most accurate and the scientist structure that we use the most, because it's kind of the most accurate, is a scientist called Rutherford. So, Rutherford's nuclear atom. What do we need to know about Rutherford's nuclear atom? Okay, so it is an atom with a dense center of positive charge and no or empty charged particles, okay, with electrons moving around the nucleus at a distance that's relatively large compared to the nuclear radius. So, for example, let us take the example of Rutherford's nuclear atom, but we're gonna do what? A helium atom. So it has 4, let's just say helium that has 4 as the mass number and 2 as the atomic number. So in this case, what's gonna happen is that we're gonna have 3 particles. We're gonna have, for now, the purple particle, which we will call it the neutron, which does not have any charge. The red particle, we will call it the proton, which has a positive charge. And then the blue particle, we will call it what? The electron, which has a negative charge. In this case, look what's gonna happen. In the nucleus, we're gonna have, first of all, how many protons? We're gonna have 2 protons. So 1, my bad, we said protons is red, so we're gonna have 1, put the plus charge, and 2, put the plus charge. But the thing is, if you look at the mass number, it is 4, and the mass number is what? The number of particles in the nucleus. If you look in the nucleus, you will see you only have 2 particles, so in order for it to be 4, you're gonna add 2 more that do not have any charge. Now the next thing is the electrons moving around the nucleus. So they usually move in their electron clouds or their electron rings. So imagine this is one electron ring, and this is another electron ring, and over here you will have an electron, and over here you will have another electron. Now, because it is a non-charged atom, it does not have a charge, you will have the same number of electrons as protons. Now, a very, very important key detail you are supposed to know is that electrons move at a distance that is relatively larger than the nuclear radius. Meaning that, okay, this is the nucleus over here. Let's take the nucleus in this color over here, green. You will take the radius of the nucleus and you will compare it to the motion of the electrons, and you will see that it will move a distance that is relatively larger than the radius of the nucleus, okay? So we move on to the next thing, which is something called isotopes. So a very important concept that we're gonna learn now is about isotopes. So we discussed what? We discussed the example of a helium atom that has 4 as the mass number, means it has 4 particles in the nucleus, and 2 as the atomic number, meaning 2 protons, but it has also 2 neutrons. But what would happen if we had everything the same except the number of neutrons? What if you removed 1 neutron, or what if you added another neutron? This is called an isotope. What is an isotope? Isotope, they are what? They are atoms that are from the same element, so from the same element, so the element will never change in isotopes, okay? They have the same proton number, so same proton, I will just say P number, okay? But a different mass number, but a different mass number. I'll refer to number as this. So if it has the same proton number but a different mass number, this means it has, so means that it has a different number of neutrons. Okay? Now, since we were discussing isotopes, we also have to discuss something else. What is the difference between one atom and another? So all atoms are composed of the same thing. You have to know, very important, is that all atoms are composed of the same 3 key elements, which are the protons, the neutrons, and the electrons. Okay, however, they have differing chemical properties. Why do they have differing chemical properties? Why differing chemical properties? This is because of what? This is because of the number and arrangement. So number of electrons, E minus means electrons, and arrangement of electrons. So different elements will have different chemical properties due to the different number of electrons and the different arrangement of electrons. So now we move on to another very important key topic, which is naming binary ionic compounds. So naming binary, very important, ionic compounds. So what does binary mean? Just from its name, binary means two. That means it's composed of two parts, which is most likely the cation and the anion. So composed of two parts. This is what binary means. So usually when we're dealing with a binary ionic compound, it is usually a cation, one cation plus an anion. Now, how do we name it? We know usually the cation, it will take the name of its metal. So let us take a very famous example, NaCl. Na, it will take the name of its metal, which is sodium. So NaCl is a very famous binary ionic compound. Whereas the anion, it will do what? It will take the root of the name, so take root of name and end with ide. Okay? So Cl, it is chlorine, so take the root of the name, which is chlor, and put instead of the in, you will put ide. So chloride. So NaCl will become sodium chloride. However, there are some cases, it is if metals form more than one cation, usually these are the transition metals. So transition metals, you have very famous example to be iron, Fe, iron. You will put that the different number of cations formed or the different oxidation number, you will indicate it for the metal by Roman integers. So transition metals form multiple cations. Oxidation number is referred or indicated by Roman integers. I'm pretty sure we've come across many examples. So 1 means I, 2 I's means 2, 3 I's means 3. Now here's where it's very important. 1, 2, 3 is the basis of everything. Then you have to memorize that V is 10, V is 5, X is 10, etc. So on and so forth. So what's very important to remember is that if you have V to be 5 and you put a 1 before it, then it's gonna be 5 minus 1, which is 4. So that means IV is gonna be 4. Then V is gonna be 5. Now if you put a 1 after the V, it's gonna be 5 plus 1, which is 6. So 2 after the V, it's gonna be 5 plus 2, which is 7. You cannot put a 2 before the V because there is already a digit referring to it, which is 3. If you do V and 3, you're gonna have what? You're gonna have 8. We know also X is 10, so if X is 10 and you put a 1 before the 10, you're gonna have 9. Then you have X, and then so on and so forth. These are the Roman numerals. They will be based on the oxidation number. So for example, Fe will form Fe2 plus and Fe3 plus. Let us just say. And it will react with what? With oxygen, so O2 minus, O2 plus. It will either form Fe2, this is the oxidation number, Fe2O, or Fe, actually I don't think, okay, Fe2O, yeah, it works, but this is gonna be Fe2O3, so it's gonna be something like this. But basically it's just like a general idea on how you are supposed to do it. Now we have a different group of anions we're gonna learn about, which is what it is called oxyanions. What are oxyanions? Oxyanions, they are what? They are anions containing an atom of a given element and different number of O atoms. So very, very famous examples we use. We have NO3 minus, which is the nitrate, NO2 minus, SO4 minus, which is the sulfate. We have CO32 minus, which is the carbonate, and etc. Anything that has what? An element and then oxygen, and it's an anion, that means it has a negative charge, then definitely it's called what? It's called an oxyanion. Now, how do we name the oxyanions? There are some rules you need to follow. There depends. If there is two, so I'm just going to open a new page for this. If you have two different oxyanions, so a very famous example is you have SO3 2 minus and SO4 2 minus. If you can have only two possible versions of it, you will take the one with the less oxygen atoms. So this one has less oxygen atoms, less O atoms. It will get what? It will get the ending ite. So gets ending ite. So this name, it's gonna be what? It's gonna be sulfite. However, this one over here, it's SO4 2 minus. It has more O atoms. So it gets the ending 8, so this name is gonna be what? It's gonna be sulfate. Very simply. Now this is the case if we have 2, but what if we have 4? If we have 4, we take a very famous example about the chlorine. So I think we have ClO, ClO2, ClO3, and ClO4, and they're all minus, if I'm not mistaken. So we have ClO minus, ClO2 minus, ClO3 minus, and ClO4 minus. Now, the one with the least, the very, very least amount of O atoms, okay, very important. The one with the very, very, very least amount will get what? Two things, a prefix and a suffix. If it has the least amount of O atoms, it will get a prefix, which is hypo, and it will get a suffix, which is what? Which is ite. So in this case, it's gonna be what? It's gonna be hypochlorite. Again, the least amount of O atoms will have a prefix of hypo and a suffix of ite. So hypochlorite in this case. Then we move on. This one is second least. So I'm not gonna say second least, I'm just gonna say second. If it has the second least amount of O atoms, okay? So let me fix the D over here. It will only get one thing, which is a suffix. And the suffix is gonna be ite. So in this case, it's gonna be what? It's gonna be chlorite. If it has third, it's closer to the most amount, so it's progressively increasing the number of O atoms, then it will also only get a suffix, but its suffix is gonna be what? It's gonna be 8, not ite. So it's gonna be chlorate. And then finally for the ClO4 minus, which is the most amount of O atoms, it will get two things. It will get a prefix and a suffix. So the prefix in this case is gonna be per, and then the suffix is gonna be 8. So in this case, it's gonna be perchlorate. Very simply, this is how you name the oxyanion. So remember, you can either have 2 or 4. If you have 2, the least one will get the ending ite, and the most one will get the ending 8. For 4, the very, very, very least will get a prefix of hypo and a suffix of ite. Then, moving on, the second one is going to have only a suffix of ite. Moving on, the third one's only going to have a suffix of 8. Moving on, the one that has the very most amount of oxygen atoms, it's going to have a prefix of per and a suffix of 8. Okay, so now you'll need to memorize some of the polyatomic ions. Let me just put the table for you. So this is a table, it's very important that you memorize. So we have NH4 plus, which is ammonium, NO2 minus nitrate, or nitrate 3, NO3 minus nitrate or nitrate V, SO3 2 minus, etc. so on and so forth. Please memorize them. They're very important for the exam because they're going to ask you probably some questions about it. Okay, so now we move on to the next step, which is, we're done with ionic, but now we will move on to covalent. But we will move on to what? To naming covalent compounds. I'm just gonna write compounds like this, okay? Naming covalent compounds. How do we name the covalent compounds? We're first gonna start with two things. We're gonna have two nonmetals, so it's gonna be the first element, which is a nonmetal, plus the second element, which is also a nonmetal. Now, how are you gonna name this is very important. So, you just need to check very important things. For both of them, you're supposed to check what? You're supposed to check how many atoms does each one have. Okay, so some important ones you can have is mono means one, di means two, tri, di not in like di, no, di in like two, tri means three, tetra means four, and penta means five. These are some of the most important. So 1, 2, 3, 4, and 5. Let us take an example. A very important example is N2O3. How are we gonna name this? Check. First element is what? Is nitrogen. How many atoms does it have? It has 2, so it's gonna be dinitrogen. Sounds like we're cursing nitrogen, okay? And then oxygen, it has how many? It has 3. But here is where we stop a little bit for the second element. The second element, we're gonna put tri first of all, but we will end, we're just gonna take the root of the name, so root of name, so oxygen, it's gonna be ox, and then we will end it with ide, so root of name plus ide, so trioxide. Okay, another example would be BF3. Okay, so B, it's what? It is boron. Now, if it's at the beginning, you do not put mono. If it's the first element, you never put mono for the first element. So you cannot say monoboron. You will not say it. No, you will say boron only. Okay, and then 3 atoms of fluorine, so tri. And then you take the root, which is fluo, and then you put ride. So fluoride. So boron trifluoride. So now we move on to the last and final step of this chapter, which is what? Which is naming acids. How do we name acids? Very simply. What we need to know about acids is that they will always have H in them. They always have hydrogen, H in them. So, let us take some examples of acids. We can take HCl. Okay, I know you know the name, but we're gonna take it as our first example. The second example is H2SO4. I know you also know, but we're gonna take it as our example. And then our next example is H2SO3. H2SO3 may be a bit different, but it's all part of the process. So, the first thing you're gonna do is you have to look at the anion. Okay, is our anion a halide? Very important. Is it a halide? Because if it is a halide, it's gonna end with what? It's gonna end with IDE. And if it ends with IDE, then you will remove the IDE. You will take the root of the second one and you will put IC instead. So I know it's very complicated, but look, this is hydrogen chloride, right? So hydrogen is H, chloride is Cl. Because it is an acid, what we're gonna do is you're gonna keep hydrogen the same, so hydrogen, but instead of chloride, you're gonna put chloric, you're gonna remove the ide and put ic instead of it, and then acid. So as you can see, I forgot, it's not hydrogen, my bad. The hydrogen will become hydro. So it's not hydrogen chloric acid. So hydrogen chloride, the chloride will lose its IDA and it will become ic, and the hydrogen will just lose the gen. So it will become hydrochloric acid. Now, the next thing you need to do for the second example is you will look at the anion, SO4. Okay, what is the anion? It is SO4 2 minus. What is the name of this anion? It is sulfate. So it ends with what? It ends with ATE. If it ends with ATE, you are only gonna take what? Gonna take the root of the name, which in this case is sulf or sulfur. You will not take the root, sorry, you will take the name, which is this, sulfur. And then you're gonna put IC, so sulfuric, and then acid, so sulfuric acid. So let's take another good example. We will take, for example, HClO3. You will take the anion, it is what? It's ClO3 minus, okay? So that means its suffix or its terminaison is what? It is 8. If its I don't know how to say it. If its ending is 8, then you're gonna take the root of its name. So in this case, the root of the name is chlor, and you're gonna put IC, so it's gonna be chloric acid. Okay, now finally, last but not least, you will check the anion of H2SO3. You're gonna get SO3 2 minus. If you see that its terminaison, I said it in French, my bad. If its ending is ite, because this is sulfite, then what are you gonna do? You're gonna take the root of the word, the root of the anion, which is gonna be sulfur, okay? Sulfur, and then you will put what? OUS, so sulfurous acid. Let us see some other examples. For example, another example is HClO3. Take the anion Cl3, no, not HClO3, my bad. Oops. HClO2. You take the anion, it's ClO2 minus. You know that its terminaison ends with ITE, it's gonna be ITE. So that means when you are naming it, it's gonna take the root of this, which is chlor. So it's gonna be, doesn't fit, let me go down. It's gonna be what? It's gonna be chlorous acid, very simply. And just like that, we finished what? We finished the summary of chapter 2. Now, I think we'll have only one exercise. So this is the only CQD, but as I'm seeing, these are a bit easy. Kim, I think you guys can do them. They're pretty simple, pretty easy. By the way, if you want any of the answers, you can open the internet to find the answers, and maximum you can ask me. But I'm only gonna do the CQDs because I feel it's the only thing we're supposed to do. So CQD1, given the following elements, an ELI, AL, Cl, Ca, which of the above elements is most commonly found as negatively charged? I cannot underline it. Negatively charged ion. Okay, so this is a very, very nice question. Why? Neon. Can it ever form an ion? No. Why? Because it is a noble gas. It does not need to form the ion because it already has noble gas configuration. Like in the periodic table, neon is a noble gas. Lithium is a metal, it will form positive. Aluminium will form positive, it's a metal. Chlorine will form negative because it's a non-metal, and calcium will form positive because it is a metal. So which one will form the negatively charged ion? It's gonna be what? It's gonna be D, which is chlorine. Okay? So now, which of the above elements has the same electron structure as Mg2+? What does Mg2+ mean? That means it lost 2 electrons. طيب, okay, look what we're gonna do. We're gonna look at the periodic table and we're gonna see Mg. Mg, it's supposed to have what? It's supposed to have 12 electrons. So if it has 12 electrons, you'll draw the first shell, 1, 2. Second shell, 1, 2. No, don't draw it like that. Draw it like this. The second shell, 1, 2, 3, 4, 5, 6, 7, 8. So this is now all in all 10. And then 2, so 1 and 2. It lost 2 electrons. That means it's gonna lose what? It's gonna lose its outer shell. If it loses its outer shell, let us count how many electrons it has. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it has 10 electrons. Okay, very, very important. And it only has 2 shells. So you're gonna look in the periodic table, which has 10 electrons and 2 shells, and it's gonna be neon. Neon is Ne. That means our answer for part B is A, which is neon. For the last one, it says, which of the above elements is found as a diatomic gas in its uncombined state? Okay, this is a very logical and easy question. Neon is already it cannot be a diatomic gas because it already has its electronic configuration. It does not need to react with anything else to gain or lose electrons or share electrons in order to have the electronic configuration. Lithium is a metal, it cannot be a gas. Aluminium is a metal, it cannot be a gas. Calcium is a metal, it cannot be a gas. So this leaves us with D, which is Cl. Logically, it becomes what? Cl2. So that's it, very simply. Thank you guys for watching. I hope you enjoyed and have a wonderful day.